Okay, second to last presentation talking about male reproductive anatomy. So I'm going to start off with some just basic general anatomical terms with the penis and the scrotum. You can see the base or the root of the penis, the shaft, the head or the glands. You can see this slide of the cross-section of a testicle, seeing the spermatic cord, the vas deferens, the epididymis, tunica vaginalis, the scrotum on the outside, the right testes, the tunica albuginea, seminiferous tubule, and the lobules on the inside. Inner anatomy, so there you can see some lymph nodes. You can see the prostate in the back. The pubic bone is forward. There's the penis, that is the base of shaft, the glands. Typically there's foreskin, scrotum, and the urethral opening at the front. There are a lot of different blood vessel veins and arteries inside the penis because it has to be engorged with blood for reproduction. So there are blood vessels. The dorsal nerve goes toward. There's the connective tissue, the urethra, corpus spongiosum, the corpus cavernosum, which are the erectile tissues that are engorged with blood. They're very spongy. This is a cross-section of our anatomical model. His name is George. So you can't see the seminal vesicles on George's reproductive inserts because it is a cross-section down the middle, and they are paired structures on either side of the bladder. So because it's just straight down the middle, you don't really get to see the mirrored structures because they would be on either side of that half slice. But they're there. Here you can see the scrotum once again, the testes, the epididymis surrounding the testes, and the vas deferens. You can see the urinary bladder, the ampulla, vas deferens, the ejaculatory duct, the prostate in the back, the bulbourethral, the bulbourethral gland, cannot speak, excuse me, the pubic symphysis, the prostatic urethra, the membranous urethra, and the spongy urethra. And at the very bottom, there's the external urethral orifice, which you cannot see, but that little arrow at the bottom right corner is pointing to it. Okay. The corpus cavernosa is comprised of two cylinders. It's corpus cavernosum. If you're just referring to one, cavernosa, it means both of them. The corpus spongiosum is always singular because it is only composed on one cylinder surrounding the spongy urethra. So there's two of the cavernosum on the top half, and there's only one spongiosum on the bottom. Here you can see the transverse view and a cross section where you can see more clearly the penile venules, which are currently uncompressed, the deep dorsal vein, the corpora cavernosa, the cavernosal arteries, the spongy urethra, the prepuce, the corpus spongiosum, and the corpus spongiosum contains the spongy urethra. It provides structure for the urethra during erection so that the passageway doesn't collapse, which is very important, and it expands distally to form the glans penis. The corpora cavernosa are two cylinders anterior to the corpus spongiosum, made up of spongy tissue that become engorged with blood, as I was saying earlier. During arousal, hormones cause the arteries that supply the blood to the penis to fully open. The blood enters faster than it can exit through the veins, allowing it to basically stay engorged with blood, helping the blood to remain in the penis, which maintains an erection. And then the hormonal state will change after arousal, which will then cause the arteries to go back to normal, basically. Here is a sperm cell. This is the male gamete. It has the head, a middle piece, and a plasma membrane around the tail. You're only required to know the head, the middle piece, and the tail. But just for fun, the head consists of the acrosome, the nucleus, the centriole, and the neck right there with the middle piece is filled with mitochondrion. And then the flagellum is wrapped in a plasma membrane. Here's the pathway of sperm. So it's generated in the testes. It then travels to the epididymis, goes up the vasa deferentia and around the seminal vesicle, then is stored in the prostate for a little bit, and then exits the penis through the urethra. So the seminiferous tubules are practically sperm factories. They can produce up to 1 million sperm cells a day. If you stretch them out, they would be nearly 3 feet long. So think of it as like a really, really, really long tube. um, Endocrine system recall, talking about from a previous lecture, the interstitial cells that are located between the seminiferous tubules, and that is where the testosterone is produced in the testes. The rate testes, sperm travels from the seminiferous tubules to the rate testes, and they gather here before then moving on to the epididymis. Macrophages will ingest inferior sperm. So sperm cells are created that are less than perfect. They get basically oh my gosh, eaten, excuse me, phagocytized by macrophages. Moving on from the epididymis, here the sperm will practice swimming and mature Sorry about that, guys. I was interrupted. The ductus deferens, enclosed in the spermatic cord, pathway leading from testes into the pelvic cavity, up near the urinary bladder. Onward to the ampulla, where the ductus deferens runs from the posterior to the inferior of the urinary bladder, where it enlarges to form the ampulla. After the ampulla, it joins the seminal vesicles, which are paired structures flanking in the urinary bladder. These glands will dump their contents into the ejaculatory duct and make up 60% of semen. The ejaculatory duct. The union of the ductus deferens and the seminal vesicles. Voila. Oh dear. Yeah. Onward to the prostate gland. It is a donut-shaped gland comprised of around 30 glands, actually, with the ejaculatory duct passing through the center, and it contributes a buffering fluid that makes up about 30% of the fluid in semen. I cannot say this word today, oh my god, so I'm not gonna. The Cowper's glands contribute to about 5% of seminal fluid, a lubricant that will buffer out any urine left in the urethra. The other 5% of semen is produced in the testes. And the urethra is a passageway leading from the pelvic cavity out of the penis. It becomes the spongy urethra once it enters the penis. Then your external urethral orifice is the external opening of the urethra where semen and urine exit the penis. Now we're going to move on to talking about birth control and the realities of vasectomy versus tubal ligations, which is like getting your tubes tied. Vasectomies are seen in society for some reason as super like demasculating, um, embarrassing, and I think that's just a load of bull hockey because it is so much so the easier procedure, and it's reversible. Vasectomies are not permanent. The procedure time is 10 to 15 minutes. You only recover in a few days. It's extremely safe and it is inexpensive, whereas getting your tubes tied, the procedure takes 45 minutes under anesthesia. It takes days to weeks to recover. It's very safe, but it can have more severe side effects if something does go wrong, and it is extremely expensive, especially with having to use anesthesia. And the no scalpel vasectomy, I have a video for you to watch in case you want to. It's a demonstration of this technique. Um, these are two different techniques. The first one is just injection, and there's no needle technique with titanium clips. And then the second one is also no needle, but it's with sutures instead. And there's a little diagram to help you understand the surgery process. And here's just an overview of some stuff that we haven't talked about yet. So you can see the urinary bladder, the pubic symphysis, the corpora cavernosa, the ejaculatory duct, bulbourethral gland, ductus deferens, all stuff that we've already talked about. But I've highlighted so that you can see the difference. This image was black and white before. But you can also recall there's the sigmoid colon and the rectum, the anus again. Yeah, just to give you an idea of where everything is together. Yeah. And that's all.